So here we're asked to sketch the functions over a specific domain, which is 0 up to 4 pi. And we can see that the two functions here are quite similar. So I'm going to start with the first one, and then we should be able to modify the first one to do the second one. So to start off with, we have y is equal to sine of 2x. And if we apply the, general form of a sine equation, it looks like this. So we have four constants a, b, c, and d that we should be able to read out. So up here we kind of have an implied 1 in front of here. So that means that our a value is equal to 1. B is the value in front of x here in the bracket, and we can see that that is 2 in our case. We don't have a plus c term in here, so essentially what that means is it's like plus 0, okay? So c would be equal to 0. And finally, we've got a d value, which would be if we had something added at the end, and we don't, so it's going to be 0 as well. All right, so these properties kind of relate to the important things when we want to plot. So one of the important things is the amplitude of our function. And the amplitude really just corresponds to the value of a that we end up with. So in our case, the amplitude is 1, which means that our sine function here is going to bounce back and forth between +1 and -1. Next we have our b value, and this kind of relates to two things. One of them is the period, which is the length of a repeating segment. And we can calculate that as 2 pi divided by the b value. And in our case, b is 2. So the 2 on the top and the 2 on the bottom cancel, and we end up with just pi. All right, so this is the length of one repeating segment of our function. So the next thing to think about, which also relates to the b value, is the horizontal shift. And there's a formula for that. It's equal to -c on b. Now, in our case, we've got a c value of 0. So it's going to be -0 divided by 2, and of course 0 divided by anything is just 0. All right, so that's telling us that actually we don't have a horizontal shift. And the last thing, our d value here, it relates to the vertical shift of our function. And in our case, it's equal to 0, so that means we actually don't have a shift at all. So now what I'm going to do is think about plotting it. So we've got our x and our y axis, and we're trying to plot a sine function, and we know that a typical sine function is starting at 0. Okay, it's got no shift, so it's definitely starting at 0. So what we know is that since a is positive, it's going to follow the normal pattern where it goes up first. So this here is one segment or one period of our function, and since the amplitude is 1, we know it's going to go all the way up to 1, and then it's going to go all the way down to -1. What we also know is this one segment is going to have a length that corresponds to pi, all right, the period of our function. So I think we were asked to draw it up to 4 pi, so we should be able to just kind of extrapolate this. So that would be 2 pi for another segment, 3 pi, I'm going to run out of space, extend this along. And one more segment is going to take us to 4 pi. All right, so what we've just drawn here is y is equal to sine of 2x. Okay, and you can see that we haven't really applied any shifts, which makes sense because ours was 0. So this is the standard thing. It doesn't need to move up or down. So that's done. So now we'll move on to the second bit, which is where we now want to plot y is equal to sine of 2x, but we've got this plus pi appearing. So I'll just pop that out. So if we go through the process again of figuring out what our a, b, c, and d values are. So a is going to be the same, it's still 1. B is still going to be the same, it's the 2 in front of the x. This time we now have a c value though. So it's going to be pi, and we have a d value, which is the +0 from before. So this time, since we have a c value, what we're going to end up seeing is that we're going to have a horizontal shift. Okay, so the amplitude, that's still a, it's still the same, which is 1. the period, that's still the same. It only depended on b, which didn't change. So the period is still going to be pi. This is where we get the change though. So the horizontal shift so it's equal to negative c on b. Okay, and in our case, c is pi now. So what we've got is a shift of negative pi on 2 falling out. And of course the vertical shift didn't change because our d value didn't change, so we don't need to consider that still. So let's think about how we can put this horizontal shift in. So we know that it's a negative value, so what that means is that we're going to actually shift it in the negative x direction, which is to the left. So if we scroll back up, I'm going to do it underneath here, because we kind of have our base case. So all we're doing is we're picking up each point on our graph and we're shifting it back the amount of our shift, which is pi on 2. Okay, so it's going to go back pi on 2, and that's like a pi on 2, that's halfway along our period, to be like 3 pi on 2 and so on. So essentially this point's getting shifted back to negative pi on 2. Alright, this point here, again it's getting shifted back pi on 2, so that's actually going to take it all the way back to the axis here. Okay, so this point is going to end up here. So if I was to like draw that, okay, this point's now here, from that point it goes down. Alright, it's a bit messy, and just bounces back and forth like we saw before. So this point corresponds to what we had up here earlier. So if we were to label it, we still know that one of our periods, alright, so the length of a repeating section, which would be to here, it's still the same as before. Okay, our period is pi. So again, another repeating segment back to here would be 2 pi, and we could continue this all the way until we needed, well, we got to 4 pi, which was what our question asked us to go to. So one more should take us to here. So this here is our graph, sine of 2x plus pi. All right, because what we've done now is we've just taken the kind of base case and we've applied that shift caused by that plus pi, remembering that the shift is not directly related to that. You had to compute it as being negative c on b. And since it was negative, we picked up our whole graph, all right, and we shifted every point back to the left by pi on 2. And this is what we ended up with getting. So that's pretty much all there is in terms of the question.